Hey guys, let's look at a problem, number of islands. It is LeetCode number 200 problem. As you can see, this is a medium problem. So the problem says that we have to find the number of islands. Let's read the description. They're saying that given a 2D grid map of ones, which indicate lands, and zeros, meaning they indicate water, you have to count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So basically, you have to connect adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay. So if you take the first example, 11110, 11010, 11000, and 00000. They are saying that we can form only one island. So what I'm going to do is just going to explain it here. So 11110, right? And 11010, right? 0110. Okay, and 11000 and 00000. Okay. So the approach is DFS. Okay, number of islands is a popular program and it's a popular question which is asked with so many companies, and it is the standard DFS approach. So basically, what you're going to do is we're just going to start iterating over the matrix. This is a matrix, and you can see it is a char two-dimensional grid. So what we're going to do is we're just going to have a count variable initialized to 0, which will count the number of islands. So we'll start from 0. And how can we start from 0? If this is a 1, which means if it is a land, then only we can iterate over it. So this is a land, of course. So instead of, there may be situations where we may visit this again. For example, from 1, now this is the 1, right? So we can move in 4 directions. We can move right, we can move down, we can move up. Of course, for this element there is no up because 0 0 and 0 minus 1, if you do it, is actually negative and that element does not exist. So up does not exist and left does not exist. But for the other elements, let's say for this one, we have got an element on its top, and it's on its right left, and it's on its right, and also as an element on the bottom as well. So the problem is, suppose you've navigated this particular one and you have reached one. If you are not marking this particular one as visited, then you may visit this and basically you'll be circling around, and this will result in an infinite loop, and finally you'll get the stack overflow error, right? So what we will do is, once we visit a land, we'll mark that land as visited. So basically I'll say 0. Okay, and then we will move down. We can move in 4 different directions. For this element, I can move left. I cannot move left. I can move only right, and I can move down. So initially I'll move down, and I will mark this as 0. I have found a land, so I'll mark it as water so that I will not visit it again. And from here also I can move down, right? So I have reached until this, but I cannot move down because it's a 0 already. But I can move towards the right. So I will mark it as 0. And from here I cannot move left, I cannot move right, I cannot move down, but I can move up. So I'll move this, and then I'll mark this land as visited. And from here I cannot move left, I cannot move right, I cannot move down, I can only move up. I'll mark this as 0. And from here I cannot move left, I cannot move up, I cannot move down, but then I can move right. I'll mark it as 0, right? And from here I cannot move up, I cannot move down, I cannot move left, but then I can move right. I'll mark it as 0. And from here I cannot move up, or I cannot move left, I cannot move right, but I can move down. I'll mark this as 0. So in a single recursive call, all elements of this grid has become 0, which means count as 1. So we have one island. Okay. So I hope this example is clear. Let's take the second example. People do not, get clarity in the first example. So let's take the second example. So it is 1, 1, 0, 0, 0. Okay. And 1, 1, 0, 0, 0. And 0, 0, 1, 0, 0. And then 0, 0, 0, 1, 1. So let's begin here. We've got an island. So let's initialize the count to 1 and then begin here. We'll mark this as 0. From here I can move down, I can move right. So let me move down. I'm marking it. So I can move right. I'm marking this. And from here I cannot move down, I cannot move left, I cannot move right, but then I can move up. From here I cannot move left, right, or down or up. So I will come back to my main function and try to search in the matrix whether there can be any other ones. Of course there is a 1 here. So I will increment the count, and from here we'll try to explore whether we can find any other islands. So I will make this at 0. Cannot move left, I cannot move down or up or right. So I have to come back again to this main function. Now let's see whether I have got any other ones in the matrix. Of course I have a 1 here, right? And so I can mark this 0. So I increment count, and from here I cannot move up, I cannot move left, or I cannot move down, but then definitely I can move right. So after this, the main function will not find any further ones to explore. So the number of islands found is actually 3. So let's code this recursive approach. Okay. So what we are going to do is, so basically do some sanity checks, which means if grid is equal to null, or if grid dot length, if it is equal to 0, then we are going to return 0 because there cannot be no islands. Now let's initialize count, which is the count of islands, to 0, and let's iterate over this grid. Remember, this is a cat grid. So let's say row is equal to 0 and row is less than grid dot length and row plus plus, and then we'll iterate over the column where we say column is equal to 0 and column is less than grid of 0 dot length and column plus plus. Okay. Now we can explore only if the current piece that we are inspecting is a land. So basically we check if grid of row column, if this is equal to a land, which is 1, right? Land is 1 and water is 0. Okay. If this is the case, we have encountered a land. From here we'll try to explore. So we'll call a recursive function which will explore in all 4 directions. So for this function, we'll pass in the grid and then we will pass in the row and the column. So this function is going to return count, which is the number of islands. So let's see how do we implement this grid of this DFS thing. Okay, so we're just going to have, you can have a private function and basically have this. So this is a char grid, this is int, right, and this is column. So what we're going to do is, if the row, if it is less than 0, we have to ensure that we're not going out of the bounds of the matrix. If it is less than 0, or if row is not greater than or equal to grid dot length, or if column is less than 0, or column is greater than or equal to grid of 0 dot length. If this is the case, it'll return because we cannot explore further. They're not within bounds. So in order to further restrict that we're not circulating back and forth again, it's the same place, basically to avoid infinite clues, what we're going to do is we're going to mark the recently visited grid, the land, as a water so that we will not backput again. So we've already counted it here, right? We have counted one. So as soon as we visit a land, we'll mark it as water so that we will not come back to it and iterate over it again and again and get ourselves uh, in an infinite loop situation. So we have reached here. So what we are going to do is we are going to explore in all four directions. So grid. So this is row -1 comma column. This will be your upward direction, right? So if you are at 1 comma 1, this will be row -1 0 comma 1, so which is the upward direction. And then we can move down. Basically any you have to move in all four directions, but then the order does not matter. We can move in any other order, whichever you feel like is good. So row +1 column, I'm going to put it in up down and left and right. So grid row is going to remain the same, column -1, this will be your left, and grid, not grid, dfs grid row comma column +1, this will be your right. So once all these functions have returned, which means we cannot explore this further, this will be our count. I hope I've not made any spelling mistakes. I'm notorious for that. Everything sort of looks good. Yeah, okay, I have missed this one. So we cannot explore further if we are encountering a water. So if grid of row column, if this is water, we have to then stop exploring. Okay, so that's it. Let's try to run this code. Yeah. Yeah, it got accepted, guys. So as you can see, the runtime is 3 minutes, not minutes, 3 milliseconds. Okay, and when you explore the time and the space complexity, if you see, if at all, if your grid is having a lot of ones, right, you have to do all this DFS and you have to go deep down until the last column. So basically, your space complexity is going to be of m into n. It's and anyhow, we are iterating over the entire grid m into n, right? So which means your time complexity is going to be O of m into n. So a number of islands, you are using a DFS approach. We are counting the number of islands by calling the DFS as soon as we encounter a land. We increment the count and then call the DFS. And in DFS, what we're doing is we're just checking whether our row and column are within the bounds and we're not exploring any water. And to avoid infinite loops, we are setting this island as a water so that we are not visiting the same land again. And then we'll try our exploration in all the four directions. And once we have explored all four directions from a particular land and we have not found any other land, then the control comes back here. And this from this main loop, we actually see whether we've got any more lands and basically increment and then call this function again and so on. So finally we return in the count. So count is nothing but the number of islands. Again, this time and space complexity both are O of m into n. So that's it, guys. Thank you. Bye.